Hello, everyone. Welcome to day two of Chaos Carnival, and that also a virtual one. I know we all wish we were doing this together, but we have the next best thing. We are live. I'm going to share a little bit about Chaos Carnival for those joining in directly on day two. We truly believe Chaos Carnival is more than just a conference. It's an experience that brings the most talented and passionate chaos engineering experts to the same stage to share ideas and chaos engineering and Kubernetes. That is quite evident from the awesome day one that we had, starting off with Mikolai talking about how important chaos engineering really is to achieve resilience. We even had a very insightful chaos panel with so many industry leaders, followed by talks about innovation, SLOs, GitOps, and so much more. I also want to quickly remind you that all the talks will be available to view on demand, so feel free to revisit them at your own time. So, what's the agenda for today? We have a virtual pancake breakfast session lined up, along with a hands on workshop, lots of games and swags, which I love, and tons of amazing talks on SLOs, resilience, and more. With that said, let's kick off day two of Chaos Carnival with Uma Mukkara, the CEO of ChaosNative and the maintainer of the Litmus Chaos project. He is an entrepreneur and technology visionary who earlier co founded Cloudbyte and Mayadata. His team built Litmus Chaos in the last 3 years to make chaos engineering easier for the modern DevOps ecosystem. His focus now is on building chaos solutions at scale for the enterprise and making chaos a first hand tool for cloud native developers. So, without any further ado, let's jump right into the keynote.
Hello and welcome to Chaos Carnival 2022. I'm Uma Mukkara, co-founder and CEO of ChaosNative and a maintainer on the Litmus Chaos project. I welcome all of you to this conference. We're excited to have all of you in this conference today. In this today's keynote, I would like to talk to you all about service reliability in cloud native. What is service reliability? What are the challenges around service reliability when it comes to cloud native deployments? And how can you use chaos engineering to improve service reliability in cloud native? Let's first take a look at cloud native itself, then we delve into service reliability. As we all know, cloud native has now achieved mainstream adoption, primarily driven by Kubernetes adoption. In the last couple of years, we have seen microservices architecture as an accepted choice for writing new applications. And many large companies are moving their monolithic applications into microservices architecture. And this migration is happening at a very large scale. This move to cloud native is being driven by CNCF. We are seeing a lot of end users are adopting CNCF technologies. As you can see here, there are more than 150 users in 2021 itself that have successfully moved to cloud native platforms. There are many technology projects being successfully hosted and nurtured at CNCF. Let's also look at how DevOps has transformed with the growth of cloud native adoption. The promise of build it, ship it, run it anywhere has made the microservices shipping much faster, and there is more dynamism in cloud native DevOps. Basically, there is a section of DevOps that is being called as cloud native DevOps, which requires different set of practices. There's one more thing that is worth mentioning along with cloud native adoption, that is digital transformation. Digital transformation and cloud native adoption are helping each other in the growth. Cloud native adoption has made digital transformation to happen much quickly and more easily. Because cloud native can do that, more and more services are going digital. The end result is we have more digital traffic, we have more digital services, we have more businesses that are digital service dependent. But that brings more importance to the service reliability. So let's take a look at service reliability in more detail now. So what is service reliability? You can say it is about keeping the uptimes with 3 nines or 4 nines or 5 nines, or you can also say that it is the keeping up of the transaction rates. With cloud native and digital transformation, it's not only about uptime, it is about keeping the transaction rates at the required level. You are not supposed to slow down the transaction rates, as dropping of the transaction rate would also means an SLA drop for the digital service. With cloud native, it's also possible that there are continuous upgrades of certain components happening all the time, so your services need to be continuously available during such upgrades. So what causes the unreliability of services? It's always about some fault happening somewhere. A service has to be reliable irrespective of a fault happening in a software or infrastructure component that make up that service. There are certain challenges to the service reliability upkeeping in cloud native, primarily driven by the two factors that make up the cloud native behavior: microservices proliferation and the delivery speed of such microservices. As we discussed previously, there are more containers or more microservices in cloud native DevOps, and they are being shipped 10 times faster or more times faster. And these microservices are dependent on each other more than ever. So if you look at the pyramid in this diagram, your app is at the tip of the pyramid and you're depending on so many cloud native components in your stack. And these components are also being changed or upgraded continuously at much higher rate compared to your monolithic world. So in effect, what's happening is you have too many services components that are changing too fast. So there's a possibility of some faults happening in the small components anywhere or somewhere, and there are also possibility of simultaneous faults or parallel faults happening. So your service has to be reliable or continuously available irrespective of such faults happening in the small component. That's a big challenge with respect to service reliability in cloud native. So let's now take a look at the responsibility of keeping up of the service reliability and which persona is responsible. Typically, we think it's the responsibility of site reliability engineers or SREs, but in cloud native, it is the responsibility of QA team as well as developers as well. So service reliability has to be the common goal in cloud native DevOps. It's also a common responsibility, not only a goal. You have to share the responsibility of building the sense of reliability in your cloud native applications. The responsibility of service reliability is not just of SREs but of all the DevOps personas. How to improve or retain the service reliability? The answer is practice chaos engineering, because the regular ways of testing will become a limiting factor when so much of dynamism is involved. Chaos engineering is one way to tackle this dynamism and reliability. We have seen why we need chaos engineering in some form, but now let's talk about what is chaos engineering, who should practice chaos engineering, where should you run these chaos experiments or practice chaos engineering, when you should run these chaos experiments, and finally, how to practice chaos engineering, what are various tools and technologies available. So what is chaos engineering? A lot has been talked about what is chaos engineering, so I'll just summarize it as injecting faults deliberately and validating the services steady state or doing a steady state hypothesis validation. That is what is chaos engineering. Who should practice chaos engineering? Everyone in DevOps should practice chaos engineering, especially in cloud native. Not just SREs, but QA and developers as well. And you can start in any area, pre-prod or prod or QA or dev, depending on whoever is interested, which team is interested, and both shift left and shift right are possible in chaos engineering. Where should you run these chaos experiments? There's a notion that you should run in infrastructure, right? Infrastructure faults are chaos engineering. While that is true, that's not all in chaos engineering. You have to run chaos experiments or introduce faults in all layers. You start in the infrastructure layer and you can move up the stack all the way till application layer. Like you can go to the middle layer, message queues and API servers, and then you can go to databases or data services and then applications themselves. Some of the most complex bugs you will unearth when it comes to reliability when APIs are responding slowly. So you need to design your chaos test to cover those scenarios as well. So when should you practice this chaos experiments? How often you should practice? So there are two answers to that. You can do randomization of chaos experiment scheduling. For example, game days. You don't tell to all the personas that you are doing a chaos test. You can do surprise testing, or you can do randomly schedule them also. For example, I'm certainly going to do a chaos test sometime today, but you don't tell when. Right? So that is a scheduled, but in a random way. The other way of thinking about this is a completely automated chaos testing method, pre-continuous deployment or post-continuous deployment, and also based on event trigger, right? For example, you have change to your application in pre-prod or prod. Based on the change, an event is triggered to start the chaos injection. How does the journey of chaos engineering practice look like in an organization? You start always with convincing your management that chaos engineering adds value. Typically, it takes few sessions. So once you get a management go ahead, you start doing game days. You test the waters of chaos engineering in your organization by doing quick game days, and you learn the gaps. So you learn how part to some extent, and then you start developing the service catalogs. The service catalog is nothing but a high level and detailed plan about your service makeup and how to go about chaos engineering of those services. So once you have that plan ready, you need skills to build the workflows or chaos experiments and run them. So you do chaos enabling sessions, trainings. You can call them as chaos thons, just like a testathon and hackathon. You can do chaos thons. Once you have the skills and the service catalog or the plan, you can start building the chaos scenarios, and you can start verifying them and automating them. You can start testing on individual components first and then start moving towards service verification. And once you have a good set of chaos scenarios, you start integrating them into your existing DevOps areas, such as CI pipelines or QA test beds or pre-prod or prod event-based triggers, and finally integrate these chaos scenarios into your observability systems as well. So as you start doing this, you will see an opportunity to improve your recovery times, and the ops teams will now have plenty of opportunity to reproduce a given failure, and you can write scripts or recovery mechanisms and reduce the MTTR, or mean time to recovery. And finally, there should be a process to periodically monitor the progress with your chaos engineering and then improve you based on the learnings. Let's now look at what makes chaos engineering at a higher level. Right? What are the constituents of chaos engineering? You can say chaos engineering at large consists of four components. One is fault injections. It's all about building chaos experiments and chaos scenarios and executing them. The other one is steady state hypothesis validation. The understanding of steady state itself could be quite challenging sometimes. You need to align the steady state hypothesis with your business SLAs, and it could be a challenge, and programming them could be a challenge, right? So that's one piece of it. The other piece is how to integrate this chaos experiments and observation of chaos execution with your existing monitoring or observability systems. Right? It's all about monitoring the service reliability during chaos execution and understanding and taking immediate actions based on the triggers that are put in your observability system. Finally, the fourth part of chaos engineering is understanding the blast radius, controlling it, and when our blast radius goes beyond your plan, you need to revert the chaos and start taking the remediation measures. So this four together makes up the chaos engineering. It's not just about injecting faults, but the rest of the three components of chaos engineering are quite important as well. So far, we understood what is chaos engineering and why, and let's also try to understand the typical challenges that you face when you try practicing chaos engineering in your team or organization. So you can summarize the challenges as the following. Convincing your management team in itself could be a challenging task. And enabling teams, as we discussed, not only SREs, you need to get QA and developers also to practice chaos engineering, and getting them skilled is another typical challenge. And once you have these two going, you need to create a larger design for your entire chaos engineering, which sets up certain goals, and that is the service catalog definition and implementation. It's like your high level design plan or requirements document for your product. You need to define your service catalog for your chaos engineering practice. The next challenge is integrating with the observability platform. There is no commonality in the observability platform implementations. Typically, you take the observability requirements and start implementing them over a period of time, and now you need to put chaos engineering context on top of or into the observability platform that you develop. That could be a time taking task sometimes, and that's definitely a challenge. And with all this, you can get going, and you will start seeing the results of initial chaos experimentation. And then comes, how do I scale this chaos across my services? And when my services are running at scale, how do I increase the scale of my chaos engineering? That's the last challenge that you typically need to deal with. So just keep in mind that chaos engineering itself is a process that you need to deal with, and it's a step-by-step winning that matters when you implement chaos engineering as a practice. And apart from these technical challenges, there are other challenges that are related. 2 about being an enterprise, right? It's about managing security while doing chaos experimentation, and also considering chaos experimentation for not only cloud native but also for non-cloud native, and dealing with the scale as we just discussed. Now let's look at how to start your chaos engineering practice. What tools you would choose, what infrastructure or platform you would choose to start your chaos engineering efforts. So typically you would need to pick up a platform or a framework that does most of the work for you, and that chaos enables your team, which really means that your teams can coordinate among themselves while developing and orchestrating this chaos experiment. So one such tool that does most of the work for you and lets your teams collaborate on experiments is Litmus Chaos. Litmus Chaos is a CNCF hosted project which is at incubating level at CNCF. Let's talk a little bit more about Litmus Chaos. Litmus is a scalable framework for practicing end-to-end chaos engineering. Let's talk a little bit about the history of Litmus Chaos. We started writing this tool back in 2017 out of a need to do chaos engineering for one of our own project needs, and then it became a need for a larger Kubernetes community. So we announced it in 2018 KubeCon as an open source project, which underwent a steady and continuous development from there on. And in 2019, we announced the Chaos Hub, which is a hub for keeping all the chaos experiments in one place, and a chaos operator to deal with the lifecycle management of chaos experiment. And in 2020, we donated this project to CNCF as a sandbox project, and we built a lot of features on top of operator and chaos hub framework to support the features for chaos engineering in enterprises. So that became Litmus 2.0, and we released 2.0 last year, and also applied for CNCF incubating process. We went through the diligence and it became a CNCF incubating project earlier this month. So overall, we made a multiple releases in this process of becoming a 2.0 and an incubating process. So for more than 60 major releases have been done, and a lot of contributions have come in. We have more than 400 contributors. A lot of feedback has been received with 1,000 plus issues. As you can see here, this project claims a good list of public adopters who have come forward and declared that they're using Litmus Chaos on a public platform. Litmus itself is a Kubernetes application that can scale horizontally. You can start small and grow big. And Litmus control plane is completely cloud native, and its execution plane can be Kubernetes environment, or it can be any cloud platform or a bare metal platform, or a virtual machine, or in a virtual environment like VMware. So to summarize, Litmus works as a cloud native applications, and the orchestration, development of chaos experiments, everything happens in a cloud native way. But the execution environment need not be just cloud native. It supports non-cloud native execution environments as well, the hybrid environment. So the architecture of Litmus is somewhat looks like this. It primarily contains three pieces. One is the chaos center, where the chaos workflows are managed, and they're managed inside chaos hubs, which is nothing but a chaos hub is a repository of chaos workflows, and they can be a privately hosted Git repository for the teams that are working on them, or you can create chaos workflows out of the public chaos hub that's out there at hub.litmuschaos.io. The second part is how you manage this chaos workflows. You can pull, um, you can put together these workflows through. You can manage these workflows through front-end GitOps as well as back-end GitOps. Front-end GitOps is where you can make changes to the chaos workflows on a Git, and you can actually view them over the Chaos Center. Backend GitOps is more of a event triggered chaos where you can start scheduling chaos experiments based on a change to an application or a change to an application environment. So this is the control plane that helps the event triggered chaos, and it is completely cloud native in nature, and all teams can come to Chaos Center, the Kubernetes RBAC method, the Kubernetes RBAC, the Kubernetes controlled RBAC fashion, and collaborate on developing, orchestrating, and executing this chaos experiments or chaos workflow. The third one is a chaos execution plane or chaos execution environment, where you will have agents, chaos agents or Litmus agents that run on the target environment, such as Kubernetes or bare metal, and these agents will take care of running and reporting back to the chaos center about the results as well as the metrics. So these three parts are loosely coupled and enable planning and execution of chaos experiments in an effective manner. When it comes to chaos experiments, Litmus has a lot of them already developed for you. We have about 50 plus chaos experiments that cover the entire range of Kubernetes resources, various cloud platforms such as AWS, GCP, and Azure, and few applications like Cassandra, Kafka. When it comes to Litmus use cases, you can start continuous chaos testing with Litmus, or start practicing game days, or start using chaos engineering in your performance engineering testbed, or you can start integrating observability and chaos together. And most of the SRE teams would love to do some SLO management or SLO verification using chaos engineering practices. These are some of the use cases. You can be more innovative in terms of finding new use cases such as CI pipeline integrations, CD integrations, pre-CD, post-CD, etc. So finally, how do you use Litmus in an enterprise setting? You need enterprise support and a backing of a good vendor, and what better vendor you need than the creators of Litmus itself to support enterprises in their efforts of chaos engineering using Litmus. So today we are proud to announce a new product, Chaos Native Litmus. It's being made generally available, and it comes in two offerings, Chaos Native Litmus Enterprise and a hosted version called Chaos Native Litmus Cloud. Let's take a look at the product announcement. to the entire Chaos Native team on building and launching an enterprise product that is based on open source Litmus Chaos. The product Chaos Native Litmus is available in two modes. Chaos is a service mode or a hosted mode or a cloud mode called Chaos Native Litmus Cloud, which is available at litmuschaos.cloud. And the other one is for on-premise setting where customers or users can download Chaos Native Litmus Enterprise and set up on their own in a self-hosted or self-managed fashion. It works well in an air-gapped setting as well. So what does Chaos Native Litmus offer on top of the open source Litmus? Chaos Native Litmus is everything Litmus, plus it provides enterprise support and some plugins to integrate into your CI/CD platforms or with your observability platforms. And more importantly, it also provides a lot of advanced experiments for non-Kubernetes targets, such as VMware and other cloud platforms and bare metals as well. How do you get started with a hosted version of Litmus or litmuschaos.cloud? It's simple. You sign up using your email or Google authentication or GitHub authentication, and you get a control plane that is readily set up for you, to which you connect your targets using litmusctl command line utility. Once you connect that, you can run your chaos workflows. Some of them are available readily for you in your control panel. And then once you run, you can collect your logs and then start seeing the workflow analytics. And to get started with Chaos Native Litmus Enterprise, you need to fill a download form on Chaos Native website. They will send you an email with download instructions as well as a license key. You set up your Chaos Native Litmus. If you require support, you can get free support during the trial period at Chaos Native Slack, slack.chaosnative.com. Once you set up your Chaos Native Litmus product, you can connect your targets using litmusctl and start running the workflows. Now it's time for chaos predictions for the year 2022. In my opinion, these are the predictions. Chaos experiments will become a commodity. What it means is that you don't need to write basic chaos experiments yourself. They'll be made available to you, and you need to build more complex chaos scenarios using the base chaos experiments. The second prediction is chaos will be available as a service. We have seen a couple of large cloud vendors making a chaos as a service available. Today we announced Chaos Native Cloud or Litmus Cloud as a service for Litmus users. And the next prediction is chaos engineering will become part of DevOps at some point of time. It is not for just ops, but also for QA and developers. That's what I mean by chaos engineering becoming part of DevOps. The next prediction is there will be more and more integrations with chaos tools and cloud native technologies. And chaos first culture will continue to get prime time acceptance. Chaos engineering is not going to be an afterthought, but rather it is going to be the first part in DevOps or creating new cloud native based applications. And finally, even though I think chaos engineering adoption will cross chasm, there is certainly an increase in the adoption of chaos engineering, especially in the cloud native space. But I believe it is next year, that is 2023, when chaos engineering adoption will cross the chasm. Thank you, folks, for watching this keynote and being part of the second edition of Chaos Carnival. Try our cloud service of Litmus. If you need any support, we are available on Chaos Native Litmus Slack. Thank you and have a good day.
Thank you, Uma, for the wonderful talk. And firstly, congratulations for the launch of Chaos Native Litmus. Really excited for that. And I'm sure a lot of the audience have got an idea of how to use Litmus, how to use Chaos Native Litmus, the ambience, what it provides, and all those kind of things. So moving into the questions, we have a few questions lined up. So starting off with this one. What is the difference between AWS FIS and Cloud Native Litmus Cloud? Chaos
Yep.
Native Litmus Cloud. Yeah.
Thank you, Sean. Yes, pretty excited about the launch of Chaos Native Litmus, both for enterprises and also as a service. The difference between FIS, AWS FIS, and Litmus Cloud or Chaos Native Litmus Cloud is that it's simply based on the open source Litmus platform, which is super highly scalable. It's a distributed Kubernetes application. And you can use this service to target chaos over all types of targets, not just AWS. It works well for AWS, but it also works well for your on-prem or other cloud services. So it's cloud agnostic, and you can connect both your on-prem as well as cloud targets to that. And generally, you will have a better developer experience with Litmus. That's what it is aimed to build, a good developer experience. It's highly declarative in nature, and you can work with your teams on developing chaos experiments in a much better way through Chaos Center. So once you sign up to Chaos Native Cloud or Litmus Cloud, you get the entire control plane, and you can start working just for yourself or for your entire team. And you can just start very, very small and then go big from there. And it's free, right, to begin with.
Awesome. Sounds really flexible. Moving on to the next question, which is chaos engineering really relevant for SQL databases? If so, how do we implement chaos engineering in traditional data storage like SQL?
Gokul. Good question, Gokul. Yes, chaos and engineering is very relevant for data and data services, which are piece of a critical piece of infrastructure, right? Data is about everything. So there are various types of chaos scenarios you can think of. You can start with the boundaries of databases, right? Database works well, but surrounding networking may cause the eventual database response to the application. So you can target some network chaos surrounding databases, and then you can go deep and start looking at IO chaos as well. In most of the cases where database or data services are involved, the challenge would be to define a good steady state hypothesis. What happens if my database data response goes down by 20 to 30%? What should we expect? Right? Should we expect a reduction in the transaction rate for the eventual outgoing service, or should it respond in the same way, right? So this is where it gets very interesting. You need to start putting that plan first and start injecting chaos surrounding the databases, and then you can go deep into it. But it's really the second or third step in chaos engineering, but it's very important for databases as well.
Got it. I hope that answers your question, Gokul. Next, we'll move on to another question by Ashwani. Can you please highlight some differentiators for Chaos Native Litmus and Gremlin?
Chaos Native Litmus is an open core product or a service that's based on open source Litmus. So it is open source, more rugged. There's a lot of acceptance over it. That's the first one. And generally, it's more developer friendly, and it's more economical as far as I know. We have targeted the price to be very attractive, and there's a free forever tier as well. And basically, you will like Litmus for its capabilities, and then you will get enterprise version of it, right? And it also is having a very good coverage for cloud native side. Almost all resources of Kubernetes can be targeted very easily. It comes very naturally for Kubernetes developers to develop chaos experiments using Litmus. At the same time, there is a lot of flexibility for non-Kubernetes as well, right? Of course, it started about 6 to 8 months ago. Covering these experiments, we have some way to cover, but basically, if you want to compare with Gremlin, you will have a much easier start with Kubernetes environments, chaos for it, and then you don't need to shut out a lot of bills.
Got it. Awesome. So we'll move on to another question, which is what is the roadmap for Litmus for the next 1 to 2 years on the line?
We've been focusing as maintainers to get Litmus to a state where it's stable as a good platform, feature rich enough to deploy it in enterprises ecosystem, because that's really the goal of chaos engineering, where services are alive, right? So now that 2.0 and 2.x is already there with feature complete for base platform, we are focusing on getting more chaos experiments for different applications, right? Not just Kubernetes, but applications that run on cloud native ecosystem or otherwise, right? Legacy ecosystem as well. So in other words, we can say that we are democratizing chaos experiments. So we have about 50. We should expect more and more application-based experiments, either contributed by us, the core sponsor team, or community. There's a lot of interest in contributing such experiments. As the usage of Litmus grows, we expect there are going to be chaos experiments that will be contributed upstream. So we will be working with the community to encourage, to put that together and make it kind of a complete set of experiments as much as possible for many different applications, right? So that's really the roadmap. We hope to get there in about a year, but Litmus 3.0 is all about experiments, more experiments. And we have a good platform right now, which is being used as we launch Chaos Native Litmus. There will be further growth in adoption of Litmus in enterprises, which really spurs the new requirements that enterprises need. So we would be developing them for Chaos Native Litmus, and we'll always upstream them back into Litmus as well. So expect more enterprisey required features being developed in the next 1 to 2 years as well, as we keep hearing, as we get feedback from enterprises.
That sounds great. Thanks, Uma, for answering all of our questions. I hope a lot of the questions that the audience had are clear now. And if there's still more questions, I've created a thread on our Slack channel. So you have to go over slack.chaosnative.com and head over to the Chaos Carnival 2020 channel. And I've already created a thread with Uma there. So if you have more questions, just feel free to drop them in that thread and he'll be happy to help you out. Cool. With that, we have 2 awesome sessions lined up right next. And we also have the virtual pancake, so stay tuned for that. But we have driving platform resilience at a startup and also improving resilience with automated chaos coming right up next. So feel free to join that. And again, thanks for joining in on day 2. Bye.
Thanks, everyone. Have a good conference. Bye.